So this video is continuing on with research design, and this time we're looking at our variables, how much detail to put in. Right, first off we're going to look at our independent variable. First off it needs to be quantitative, not categorical. Make sure you have units, and this is surprisingly the thing that often students kind of trip up on. So the reason why they trip up on it is potentially later they might find a reference value for their substance. So how much vitamin is meant to be in oranges, or how much caffeine in coffee, and that value will have units. And if you want to do accuracy, you will use that value, which means you will put your answer in those units. Let's say milligrams per 100 grams. Now, your independent variable should match the unit of the reference value if you can find one. Okay, and that'll give you a chance to talk about accuracy in your conclusion, so that's very useful. And by quantitative, I mean something where you can change it bit by bit, rather than categories, like different types of shampoo, for instance, would be categorical. Now, sometimes there are things you think are categorical that you can manage to make into quantitative. So I had a student who was doing glow sticks, and she had 5 different colours of glow sticks. We were able to take a photo and use a website to find the wavelengths for those colours. It's not perfect for a number of reasons, but it did mean that she then had quantitative data, which really helped her when she came to her conclusion. Right, so specifically you need to justify your range, your interval, or your frequency. So range is the lowest value and the highest value. I would like you guys to think about, so often people are heating something or leaving something and they forget to do a 0 value, so a value where it's not been left open or not been cooked or not been heated. This is really useful to have, because then you are talking about the change from whatever the substance was like to begin with, but also often your reference value will be comparing against that that 0 value. So especially if you're heating anything, try and remember to do a 0 in your range. Interval is how far apart they are. Now, and that's, or frequency. And for that you need to think about trying to get usually as long a time frame as possible, but one that makes sense within the limitations of the classroom. Okay, so doing it for a number of months is clearly impossible. You could do days or even weeks. If you're leaving stuff open over the summer holiday, it can be possible. I had a student who was leaving sake open to the air to see how much turned into vinegar. He slipped up on that, unfortunately, but was able to do it with open for a certain number of days instead. So maximum range that you can get within the limitations of your experiment. Obviously, if you're using water to heat things, 100 is always going to be your limit. Sometimes you might be justifying it in terms of what is realistic. So how hot the environment might be that you're examining. Okay, right, moving on. So this is a table that I would recommend using, or something similar. This is for your control variables. So I've picked 2 control variables for the research question I spoke about, which was looking at how roasting time affected the amount of caffeine, and that was using an iodiometric back titration, where you add excess iodine and see how much is left over when some of it's reacted with the caffeine. So for each one you want the method of control. Okay, you need to be thinking about precision. How precisely am I going to measure it? What piece of equipment am I going to use? So we've got two here. Here I've kind of combined concentration and volume of iodine, as in you're adding excess iodine, but you need to know how many moles excess you're adding, and this is how you control it using 25 cubic centimetre pipette. I should maybe actually put in there 25 cubic centimetre volumetric pipette plus or minus 0.08, I think is the uncertainty for those, but you'd look it up on the piece of equipment. You should also be talking about why you're doing that and how it affects your data. So for the first one, if I had more beans than 50 grams, when I made the coffee that I was testing, that coffee would be more concentrated, it'd have more caffeine in it, and therefore I would overestimate the amount of caffeine per 100 grams of coffee beans. If I added too much iodine, then when I did the titration, again, I would be overestimating the concentration of caffeine once I process my data. So what I tend to do is suggest you just pick a direction. If it was too big, what would happen? And then just put and vice versa. Okay, but this way you're really thinking about the impact of it. You're not just saying, oh, it will impact. It's how will it impact? If I've got heat loss, what does that do to my final result? Okay, and again, this will help with your conclusion and your evaluation, because potentially you can start to judge which of them, if one is acting in one direction, one is acting in the other, you can maybe start to see which of these effects will have the most impact. Now, as well as this, and I've not put it in my PowerPoint, as well as this, you should also have a table for uncontrolled variables. And these are ones that you can't, this kind of says it, you can't control. So I can't, for instance, control how the coffee beans were stored before I bought them, but I can try and limit the impact. So with uncontrolled variables, you can try and limit, even if they are uncontrolled. If, for instance, you're doing something with gas pressure or volume of gas, the atmospheric pressure actually will have an impact on that one. Normally we say don't worry too much about room temperature and pressure, but if you're specifically finding the volume of a gas, the atmospheric pressure will make an impact. So there's things you can do. You could try and measure it. If that's not possible, you should at least talk about how it would impact it. So a higher pressure would decrease your volume and vice versa. So this is my little list of points that I would expect when you're going through your methodological considerations. That is basically your variables. So independent variable, units, the increments you're going in, and a discussion of why you picked that range, interval / frequency. Consideration of repetition, we always say a minimum of 3, because then you're more likely to be able to spot anomalous results. And precision, so that's which piece of equipment are you using to try and keep the uncertainty of the measurement as low as possible. Minimum of 5 independent variables over as wide a range as possible. If I was looking at the effect of temperature on caffeine, doing 20 degrees, 21 degrees, 22 degrees, 23 degrees, 24 degrees, 25, with only 1 degree difference, I'm unlikely to see a very significant change in my dependent variable. Dependent variable, as it might be as calculated. So what are you going to be finding out in the end? You might have a titer and that's a volume, but at the end you're going to be finding a concentration with that, correctly identified with units. Dependent variable should be quantitative, though you may well be taking qualitative data as well. Relevant control variables, so room temperature, if you're only working in solids or you're heating to a temperature of 100 degrees, small changes in room temperature aren't going to make a massive amount of difference. So be sensible with your control variables. Human error is not an uncontrollable variable. Method for control variables is detailed tools, units, and uncertainties. Okay, so again, use that table I suggested. Controlling the temperature of the room is actually unsuitable, but if temperature you think is relevant, well then at least maybe you should be measuring it.